All right, we're going to make a video key here. So first thing I would do on this first problem is I'd use substitution. I'd take negative 2x plus 4 and I'd put it in the other equation for y. So after that, I would have negative 2x plus 4 is equal to 1/4 x plus 2. All right, I don't like having fractions in my equations, so I'm going to get rid of them by multiplying everything by a common denominator, which in this case would be 4. So I'll multiply the left side by 4, the right side by 4, and I'm going to clean this up. So I have negative 8x plus 16 is equal to 1x plus 8. Get all the x onto one side. I'm going to move them on the right side so they're positive. So I have 9x over there. And if I subtract 8 from both sides, I'm left with 8 over here. So x is a fraction in this problem, which is going to be 8/9. Okay, so there is half of our solution. To find the other half now, we just take that value and we go back and we substitute in either equation for x. So I'm going to put it in the top one. Negative 2 times 8 is negative 16. So that's going to be negative 16 over 9 plus 4. Okay, so let's see, negative 16. Let me see, did I make a mistake before there? Let me see that. I added 8x to both sides and I subtracted 8, so that's positive 8/9. So negative 16 over 9 plus 4. Oh, that's good. So then what is 4 in ninths? That would be 36/9. And so that would be 20/9. So y equals 20/9. Good. So then we write our equation answers to the solution of the solution to the system of equations as an ordered pair. So if these two lines, if we graphed them, they would intersect at the point 8/9 and positive 20/9 for y. Okay, so I would use substitution. You also could have used those on graphing, but they weren't very neat graphing ones, so it wouldn't work out perfectly. The second one, I would also use substitution again. So I would take this x minus 2 and I would put it in the other equation for y, and make sure you substitute using parentheses, especially here because you have a coefficient in front of that y. So we have x plus 5 times the quantity that's equivalent to y is x minus 2, and that's all equal to 20. So take x plus, this is where people make mistakes. If you don't use parentheses, you got to distribute. You might forget to distribute to that negative 2. So this would be, this would be 6x minus 10 equal to 20. And 6x is equal to 30 if you add 10 to both sides. And so the x value there is 5. Okay, so we got half our solution there. Now we go ahead, we take that 5 and we plug it back into the easiest equation, which would be the top one for x. And so y is 5 minus 2, or 3. Okay, and again, you write your answer as an ordered pair. In this case, it'd be 5/3. All right, moving on. Next question, I would use elimination for this one. And I would multiply the top equation by, let's just go with 3. And that'll eliminate the y. So 3 times x is 3x minus 3y equals 9. Combine those with the other equation. I'm left with 5x. The y's cancel out, which is what I want. Those are eliminated. And 9 plus 6 is 15. So 5 times what number is 15? That would be a 3. Okay, there's half of my solution. The other half I have to back substitute. Put 3 into either equation. If I put it in here, 3 minus what number equals 3? And that would be 0. So the solution for that one is 3, 0. If you graph those two lines, they will intersect at 3, 0. The last problem is a inequality, a system of inequalities. And the only way to really represent this solution is with a picture, because there's so many different possibilities for x and y that make it true. So we're going to graph both these, and I'm going to use intercepts to graph. So for this first one, my x-intercept, remember that's for y is 0. If I put 0 in for y, that gets rid of that. When does negative 4x equal 4? Negative 1. That's a really big concept to understand. Some of you guys are catching on to that, and I noticed some of you guys haven't grasped that yet. So you want to make sure you get that understood here sooner than later. If you want to find the y-intercept, that's where it crosses a y-axis, we know x is 0. So if I put a 0 in for x, that makes that 0. When does 2y equal 4? That's at y equals 2. Okay, so now I can graph that using my intercepts. So I have negative 1 and 2. So negative 1, 0 is going to be right there. And 0, 2 is up here. And there is a line that goes through those points. Sometimes if I have the graph paper, I like to just keep extending that slope. And you can see here it has a slope of 2. So if you rewrote that equation in slope-intercept form, it should have a positive slope of 2. And hopefully it's solid. I didn't look. Let's see. Yep, it is solid because it is greater than or equal to. So solid line. And if I do a test point, which is what I recommend doing for these equations that are in this form, if I check 0, 0, I would have 0 minus 0. Is that greater than or equal to 4? That's false. So 0, 0 is false. So that means that you shade the other side of this line. And so all the solutions are all the ordered pairs, all the x and y values that are above that line. The other one is also set up pretty well for well, you can do this actually either way. If I graph this one using slope intercept, which is a little different, I move that x to the other side by adding x. And so this would be y is greater than or equal to x plus 1. So that means it has a y-intercept of 1 and a slope of 1. So this line is going to intersect right there, and it's just going to keep going. So do my best to draw a graph. Anyway, not a perfect line, but you get the point. Since this is solved for y, and y is by itself, if it's greater than, then we can use the shortcut and say, yep, if it's greater than, I always shade above. So now it's above the red line as well. So the solution to the whole system is above the red line and above the purple line. And so it would be that overlapping area, which would be right here in this region. So there you go. That is all the points that are in that area that extends forever are the solutions to that system. Okay, so that takes care of this first part of the chapter, and happy studying. I hope that helps.